Hi there, we are the Techy Tubbies, and this semester in our robotics class, we worked on some engaging activities involving servo motors, I2C LCDs, and ultrasonic sensors. In this video, we'll walk you through the activities we completed and share what we learned throughout the semester. We hope it gives you a clear idea of how interactive and fun robotics can be.
When we work with the servo motor, we realized we could really control its movement. It could rotate 90 degrees and then go back to its original position. The servo motor does not just rotate all the time like a DC motor, but it stops exactly where you want it to. We also learned a lot about controlling the angle, including from a task we did where the wires had to be placed correctly so that the servo motor would move properly and stop at the right angle. We also had experiences where it was challenging because we placed the wires incorrectly, and there were times when the servo motor moved differently than we expected and would suddenly stop moving.
The ultrasonic sensor measures how far or close our hand is from the sensor. It also measures the sound waves that travel through the air and hit an object to sense the object near it. Using the serial monitor in the upper right corner of the screen, we were able to observe the computer distance. Merely by examining what we have done, it could easily determine it is accurate, since if we move our hand closer to the sensor, it will detect that something was closer or distant from it, but it can only sense 2 to 4 cm distance clearly. If there are factors that affecting its reading, it is an obstacle, the movement that didn't notice and that can prevent it from reading precisely. The ultrasonic sensor enables interaction if the system senses the motion and the distance from the individuals that are near or far the sensor. The message we enter into our coding was what the information the I2C will display. There is a factor that is important in our I2C LCD display, and it is a feedback. In robotic system, feedback is important because it can actually identify if the I2C LCD display was accurately working or not. It also helps us to confirm if the coding was sent and received by the I2C LCD and displayed correctly. The I2C greatly simplify the wiring compared to the regular LCD connections by reducing the numbers of wire we needed and making the wiring easier and reliable. This I2C help us during the debugging by giving us feedbacks about what we program.
The components work together as a single system to perform tasks and activities. For example, there was an activity where we have to make the I2C LCD display the distance using the ultrasonic sensor. In this system, we use the ultrasonic sensor to calculate its distance from our hand. As we move our hand farther or closer to the ultrasonic sensor, it calculates the distance between them. It sends the information to the I2C LCD to display the distance between the hand and the ultrasonic sensor. This system functioned as the ultrasonic sensor and the I2C LCD work together as recipient and feedback. This interaction made us realize that in automation, every detail matters. It is just a matter of understanding how components can work together in order to perform tasks.
The most challenging part of the activities was figuring out why we failed to execute them correctly. There were a few shortcomings with the execution. There were multiple faulty components in our kit. For instance, there was an activity where we have to make a servo motor move using a potentiometer. As we turned the knob, the servo motor was not moving as it was supposed to. We searched for all sorts of errors like checking if there were misplaced wires or if the potentiometer was entirely plugged into the breadboard. It turns out that we were using a faulty servo motor. When we replaced it, the servo motor moved as we turned the knob of the potentiometer. There was also a time when the currently selected board was incompatible with the Arduino Uno. We could not proceed into coding because of it. We then switched the board to Arduino IDE, making the code run smoothly. We also encountered problems when making the I2C display button pressed when the button is pressed. We asked for assistance and then realized that the button was not entirely plugged into the breadboard, which caused the malfunction. The foundation of our group has always been teamwork. We improved gradually in terms of logic and testing. We were able to analyze the problems and errors by ourselves without needing constant assistance.
As grade 11 students taking robotics class, we thought that robotics is a complicated subject because it is more about technology, which none of the members are really interested in. At first, we were overwhelmed by the activities and components since they were unusual to us. But over time, we got the hang of it. We learned how each component works together as one system, such as servo motors, I2C LCDs, and ultrasonic sensors. The most valuable skill we learned in robotics is problem solving because we needed to find and fix errors in the code and wiring to make the system work properly. This skill can help us in future subjects and activities by allowing us to solve challenges more easily, especially in technology-related tasks.
One of the most significant takeaways from a robotic class is that learning robotics is a step-by-step process that involves trial and error. For future learners, we hope you embrace challenges and see mistakes as chances to learn because every failure in robotics teaches you something new.